Well, so far you learned that to make a map you need a projection, and the projection needs a coordinate system. The coordinate system itself needs a datum so that it relates to the coordinates of the physical Earth. Now, for the datum to be able to propagate the coordinates to the flat map coordinates, the datum needs to have a coordinate system attached to itself. Now, as you know, a coordinate system needs to have an origin, and the origin usually is set to be the anchoring point of the datum. So for WGS84, for example, that origin would be the center of the Earth. The same goes for NAT83, but with some slight millimetric variations. This coordinate system attached to the datum is referred to as a geographic coordinate system, and it describes each point on Earth through geographic coordinates known as longitude and latitude. So a pair of longitude and latitude values may look like these. These are angular coordinates, meaning that each of them is actually an angle. So how are they measured? Well, the coordinate system has a reference meridian known as the zero meridian. And for WGS84, that meridian is the line connecting the Northern Pole, the Greenwich Village in Great Britain, and the Southern Pole. And as you know, there is also a reference parallel that coincides with the equator. Now let's see how we would describe a point somewhere in US. Let's say here. The longitude of this point now is the angle between the reference meridian to the meridian that passes through that point. That's what longitude is. Now, if the point is east of the reference meridian, the longitude will be negative. If it is west of the meridian, it will be positive. And what is latitude? Latitude is the angle between the equatorial plane and the straight line that passes through the given point. If that point is in the northern hemisphere, the latitude will be positive. If it is in the southern hemisphere, it will be negative. So this way, every point on Earth has its meridian and parallel, which are nothing more but these angular values that I just explained. But there is a third value as well, which is taken into consideration when 3D applications are concerned. That is the elevation value, usually denoted with an h. The elevation is the distance from the surface of the ellipsoid to the given point, and that's how the unique position of every point on Earth is specified. Now you may ask, who is measuring these? When GPS technology didn't exist, these were measured using optical devices that involved astronomical observations. But now with GPS, you get the longitude and the latitude displayed on your GPS device screen or even on your smartphone right away. And if you're curious about how a GPS system is able to find the coordinates of every point on Earth, please follow the next interesting lecture. See you there.